All right, we are going to be looking at the sea star dissection. So I have Pyzaster ochre here, and you can see a couple of features on the external anatomy first. So you have a number of the spines that are coming up through here. You can't see any of the smaller structures, but we'll be able to see some of that on the cross section of one of the arms on a slide in just a moment. Another thing that you can see here is the madreporite. This structure is going to be helping to move seawater into the animal's water vascular system. We won't get to see much of the water vascular system other than the tube feet. So here you're seeing 5 rows of paired tube feet. So you're seeing the tube feet extending down in between the grooves of each of the arms. In the center is the mouth. On the sea stars, they do not have a specialized mouth, but we'll take a closer look at some of the variations in that structure later on. All right, so to make this dissection, we're actually going to open up 2 of these arms, and we want to cut away from the madreporite so that we don't accidentally cut the stone canal. That allows the water to move from the madreporite down into the ring canal, which is part of the water vascular system. So I'm going to do kind of just a simple cut at the end of the arm, and that's just going to allow me to get access to the sides of the arm. I mentioned in class already that this is a fairly simple dissection. And I like to use scissors a lot of times because of the greater control. So these structures that are coming down now that were stuck up on the arm, these are the pyloric ceca. They are connected to the pyloric stomach and function in releasing enzymes for digestion. Just clear a little bit more of this. I'm going to come down the other arm now, just trying to be careful of not cutting too many structures. Most of the organs, as you saw in the first arm, are near the top of the arm, so I'm just going to cut partially here. And just stop for a moment and make sure the structures don't get stuck to the surface, the inside surface tissues. At this point, we're going to be a little bit more careful with the cutting. So maybe we can even see that stone canal. So I'm going to remove some of the structures here. So again, you can see, just be a little careful, they're a little delicate with the pyloric ceca. So each arm will have a pair of pyloric ceca that extend down from it. So that would be repeating in the other 3 arms that we're not going to cut away from. Cut here, and then I'm going to see if we can get around the madreporite. Carefully try to peel this off, keeping as much of the organs intact, because that's how you're able to determine the structures, is what they're connected up with. So I'm going to zoom in here so that you can see a little bit more on the features before we go any deeper on our dissection. So what we can see here, this very flat part of the body is what we call the pyloric stomach. The pyloric stomach is connected, or was connected, to the pyloric ceca. So here is where mainly digestion is going to be occurring in terms of breaking down the food even smaller to get into the body's tissues for absorption. the anus has now been cut away. The anus would have just been straight up above the pyloric stomach. So echinoderms have an alimentary canal, if you recall, a separate mouth and anus. So again, the mouth is on the ventral side and the anus is on the dorsal side. And so the anus being here, very small structure that. All right, so we're going to go down a little bit deeper and going to remove the pyloric stomach. And below the pyloric stomach is a larger stomach. You can actually kind of see the pouches of the stomach extending out here. That's called the cardiac stomach. The cardiac stomach has nothing to do with the heart. In that terms, and here you can see the mouth. So I've actually opened up the cardiac stomach. It's a delicate structure. But you can see the mouth here. What's very interesting, you can see that there are no teeth or any other form of mouth parts for chewing the food. So what the sea star is going to do is it's going to push its cardiac stomach out through its mouth, release digestive enzymes from the pyloric ceca into the pyloric stomach. Those enzymes are going to come out into the prey. So say this was a sea star holding open a mussel. It would dump all of those digestive enzymes onto the mussel, wait for it to become more or less soft and liquefied, and then it would suck it up into this big pouch cardiac stomach and pull it into the body, and then continue digesting for absorption. So that's basically all we're going to get there. If we look carefully, if the structure's intact, we can see it there. We can see the stone canal. So I'm going to pull a little bit of tissue away so that when I lift this, you'll be able to see it a little bit better. So again, here's the madreporite right there, and leading is the stone canal, that tube right here. So that tube is going to allow water to enter into the body, and I'm going to remove some. So again, madreporite on top, this is the stone canal coming down. So then within this groove here is going to be a circular ring, so we call it the ring canal, that water will be distributed in. And then within what we call this ambulacral groove, so you can see here in the arm, this is the ambulacral groove. Underneath that, within the body of the animal, will be the radial canals. From the radial canal, then, are these little balls that are extending off of that. And if you recall from lecture, those are the ampulla of the tube foot. So each ampulla has a tube foot associated with it. And so within the tube foot, there are retractor muscles, and within the ampulla, there are extensor muscles for the tube foot to help it move. Gonna remove the pyloric ceca and see if there are any gonads under here. And it's very, very simple. We're just going to take a
So the gonads are too small for us to be able to
the gonads.
Look for the egg or sperm, but here they are.